Vacuum balloons. I want some. Vacuum balloons. I want some. Forever, ever, ever. Going high, 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 high. Wow! YouTubers, welcome to another video. Look at this. Vacuum balloon technology. Yeah. I figured it out. I figured it out. Because I wanted my balloon to fly forever. My Disney balloon to fly forever. And how are we going to do it? We're going to have helium-infused bubbles in polycarbonate microbubbles. We're going to have a vacuum pellet processor and a hot oil bath that sits there, and you have a magnetic spin rod that spins that thing up, and we have lasers sitting there, and we're going to have this thing just go, and as it expands, the pores inside are going to expand, and we're going to have this really cool vacuum balloon made out of polycarbonate. Now, what is a vacuum balloon? Now, typically, you can't make a vacuum balloon because if you put vacuum in a balloon, it just goes, because it's a consumer. It sucks down, it implodes. This one won't allow for that because this one is made of polycarbonate. You've got a polycarbonate foam that prevents the collapse from the atmosphere at 14 psi. And the target volume, of course, is going to be 1 meter cubed. So it's going to have a lot of cool things. Now, why is this going to work? Well, we look at the buoyancy of vacuum versus hydrogen. Hydrogen is 93% vacuum, helium is 86% of vacuum, and of course you get air, H2O, hot steam, you get between 38 and 50% of lift or buoyancy versus the atmosphere. This is for castles in the sky, like that one there. That one's really cool. You know, we got this closed skeletal structure, and if you ever dealt with like foamed plastic, that is some super tough stuff. But we're doing some magical things here. And the magical things we're going to do here is we're going to start with the helium-fused polycarbonate pellet, and we're going to put it in a vacuum chamber. And we're going to have lasers targeting the pellet, and we're going to have it's going to sit in hot oil, because you can have a vacuum and also have hot oil. And we're going to have a magnetic spin rod that spins that thing up, and it spins and it sits there and it heats it up, the lasers heat it up, and it goes, and it blows up like a balloon inside the vacuum chamber, and then we're going to go exit aperture, and we're going to open up the exit aperture, and it's going to go, because we're going to have these little things that let it to lift it right off the oil after we've got it to the right expansion. And then we're going to vary. It's going to be like a vacuum flutter to get that thing up off the oil, lift it up in the air, and it's going to cool off. Hopefully relatively quickly. And it's going to be spinning, so there's going to be a spin rate too. We're going to have little nozzles and vacuum inlets that are going to allow for that thing. And didn't you always want your balloon to float forever? I mean, you went to Disney, you're like, woohoo, I'm at the park, it's really cool, and you got my Disney balloon, I'm taking it home. And I remember mine, it floated for almost a week in my room, and then one day it just went down, 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 down. I even set that thing, I laid it down on top of my dresser, and I'm like, I wish you still flew. But, you know, the big mouse can't solve all the problems in the world, but this will solve a lot of problems. So if it wasn't for my mouse balloon, this wouldn't have happened. So I tell you what, this right here, vacuum balloons, it's going to be cool. Now, how does it work? Well, the helium is actually pretty interesting because the polycarbonate porosity structure, as defined by positron annihilation lifetime spectroscopy, has an average hole radius of 2.7 angstroms to 2.77 angstroms, and diameter of helium is 3.1 angstrom plus or minus 0.3 or 0.3 angstrom. So that's going to mean that if you put helium inside polycarbonate, it won't leak out. It can't. The porosity of polycarbonate is too small to let it in, so it's going to hold it in there like a cage. That's interesting because I haven't seen any polycarbonate containers, or usually they use like aluminum or steel for the helium tanks. But let's talk about what we can create. Okay, so the target volume is 1 meter cubed. 1 meter cubed or spherical. What, you got about like that. And because it's polycarbonate, it's rigid. It's rigid. It won't fall back down. And it's also very lightweight. And that's what we had to do. We had to find that combination of rigidity and weight reduction. You can't make it out of a lot of different materials, and polycarbonate is one of those materials you can do, and it allows us, because polycarbonate is what? It is transparent, we can now shoot lasers into it and make the whole inside glow, and that allows us to heat up the inside evenly with a spread focus laser, and it allows us to put it in the vacuum chamber right there and allows it to grow. Using lasers and hot oil and vacuum, the pellet is expanded and allowed to spin with short bursts of air, probably short varying vacuums entering the melt chamber, and the spin rod in the oil spins it up, and the bubble expands. The bubbles expand internally as the centrifugal force forces the foamed bubbles to move out, the material moves out, causes the internal structure. It ends up more like a biological bone structure. You're seeing it's almost like a cross-section of a bone, right? Which is very, very strong. And that's what we want. We want the sphere that's very, very strong. Now, we're going to make this real, real short because we don't want to take up all your time today, but it allows you to use massive nets holding vacuum balloons, and you can now make big platforms in Sky Cruise hotels, and it's going to be awesome, and this is the future, and it's here, and welcome to the future of... This is going to affect everything. You're going to have sky platforms and the ability to... I mean, wow. Safe air transit. Kind of safe. It'd be interesting though. You'll be able to have sky hotels, you're going to be able to have sky houses, sky cars, all this other thing. So now you can create vehicles that don't need to have like spinning death rotors to keep you in the sky. And super noisy, it's going to be silent. This has so many applications. What would you pay for a ride to the sky? Would you pay for a sky house? Would you pay for a sky car? Would you pay for all these other things? How much would you throw at this technology? Well, I hope you throw a whole bunch and get it out there as fast as possible because the world needs it right now. Let's go. Once again, I am Zio, 205IQ. Thank you for watching, and I hope you march to the future.